Hello everyone, this is our lecture video number 12 and this is the last video in this video series. So we will see what is FEA software or FEA tool. Okay, so I will try to show you what exactly what goes in the background of FEA software. Okay, so I am not going to show you the details no, what goes into background, but as an application engineer what we need to understand or what we need to know, that I will try to explain as per my understanding. Okay, so in FEA software, okay, this element stiffness matrix, okay, or element level characteristic matrix, right? We have seen. So we know like all these stiffness matrix are different for different element types. Okay, even like if I discretize domain into let's say 10 number of elements, all 10 elements be, let it be all beam or bar elements, the stiffness matrix will be a different, right? The values uh, in that matrix will be a different for each element. Okay, so one, what is a FEA software? Okay, in FEA software, uh, for different element types, this element stiffness matrix are programmed in a prior. Okay, so they will program the stiffness matrix for all beam, bar element, quadratic, first order, second order elements, hex, stat, everything. Okay. Then what next? Generally in Python, if you know the Python language, the array, something called array is used to represent the matrix and vector. Okay, this is just for information. Then what next? Okay, when user does meshing in a software, okay, in preprocessor of that particular FEA tool, the software calculates the element stiffness matrix for each element. Okay, let it be thousands or millions of elements, it does it for each and every element. Okay, and then it forms a global stiffness matrix for the entire structure. Okay, so we would have done the meshing. Okay, so it forms a global stiffness for each element. First it will calculate the stiffness matrix and then it will form the assembly of this stiffness matrix. So software no, first it does a node and element numbering. Okay, node and element numbering, then based on connectivity of elements it forms a global stiffness matrix, okay, for entire this structure, and it will also form a global displacement and global force vector. Okay, so with this the we will have global system of equations in a software or in a program, okay, in matrix and vector form. Then what else? The user, as we know, FEA engineer or FEA application engineers, we give all the inputs including loads and boundary conditions. Okay, so the computer program or FEA solver in the FEA tool, it will substitute these loads and boundary condition and it will solve these equations. Okay, so these are no, generally they will have different linear solvers. The softwares will have linear solvers and they will use that linear solver to solve the linear equations, which are nothing but no, a, okay, ax equal to b. Okay, if I am not wrong, this is the notation. So this is nothing but kx is equal to our stiffness matrix, displacement and force vector. So these are linear equations. So software has a linear solvers, different linear solvers. For example, direct linear solver or iterative linear solver. Okay, even I am not much expert into this. Okay, if you know, if you would have heard Gauss elimination method, so these are different methods to solve linear equations. Okay, so these are also programmed into software and software will solve the global system of equations. Okay, so that's how it works. Once they find the unknown displacements, okay, displacements which are unknown from the global system of equations, they will solve that. And they will also find other quantities, okay, other quantities like element level quantities, uh, for example stresses and strains. Okay, so this is just a very basic overview of what is FEA software. And as an application engineer, this is more than sufficient to know. Okay, uh, uh, yes, for a software developer, okay, for a FEA software developer, if you are, if you want to aspire to be a software developer and want to build a career, then you need to know all the details. Okay, like what are linear solvers, what are direct iterative solvers. Okay, uh, so those are the things. Even nowadays, no, all this, for example, if we take a Python or MATLAB, okay, we take a Python or MATLAB programming language, okay, they also have inbuilt solvers, okay, inbuilt linear solvers. So it is like, if we take Python, okay, once we have global system of equations, okay, for example, in Python, SciPy, NumPy, they have linear solvers inbuilt, or library of this functions are inbuilt into this programming language. So once we have global system of equation, it is like, very few lines of code, or we can say single line of code, uh, that no, that is for solving linear equations. Okay, so we just pass kuf uh, into that single line of code. Okay, and software will give the solution. Okay, so even we don't need to know the programming or solver details itself. Okay,